Hey everybody, today we're going to talk about the rational zero test. So if we have this polynomial right here, a sub n, x to the n plus blah blah blah, all this stuff, and it has integer coefficients, so all the a sub n's are integers, then every rational zero that this thing might have, now remember rational numbers are numbers that can be written as fractions, okay? They have the form of p over q, where p are the factors of the constant on the end here, and q are the factors of the leading coefficient. Okay, so that might not make a whole lot of sense just yet, but if we look here at this one, we want this equation right here. We want all the possible rational zeros of this thing. Okay, it would be factors of 1, which would be plus or minus 1, divided by factors of the leading coefficient is 1 also, plus or minus 1. So my only choices here are plus or minus 1. That's it. That's the possible rational solutions to this. Now, they may or may not work. Okay? In fact, neither one of these will work, because if I plug in 1 here, I get 1 plus 1 plus 1, which is 3. That's not a 0. And if I plug in negative 1, this is negative 1 plus negative 1 plus 1, which is also not negative 1. So this one actually has no real rational zeros. But these would be the only possible ones that could occur. Okay? Now you can factor things over rational numbers, over fractions, where the zeros are fractions. You can factor over real numbers where they're, they can be square roots and things like that, or you could factor it over the complex numbers where you could have imaginary solutions in there. Okay, let's look at this. The possible rational zeros of 2x cubed plus 3x squared minus 8x plus 3. So it's going to be plus or minus 3, or 1 and 3, I'm sorry, because those are the factors of 3, divided by plus or minus 1 and 2. So my possible rational solutions would be plus or minus 1, 3, 1/2, because 1 divided by 2, or 3/2. This has 8 possible rational solutions. Okay, and if I wanted to find which ones worked, I could do it by synthetic division. So I would take the coefficients 2, 3, negative 8, and 3, write them down like this, bring my 2 down, and then I would choose one of these. I'm probably going to choose something small for this one, like 1. 1 times 2 is 2, that makes 5. 1 times 5 is 5, that makes negative 3. 1 times negative 3 makes negative 3, which makes 0. So that one worked out good. So I know that 1 is one of them. Now, 1 could occur again, but here's what I'm going to do. Since this was an x cubed and I divided it out by an x, this is x squared. So this equation is now 2x squared plus 5x minus 3. And I would rather factor that than try to figure out which of those other ones work in here. So I can go 2x and x. I need to make 5 in the middle, so I'm going to put a 3 there because that makes a 6, and a 1 there makes that a 1. So I'm going to go plus 6 minus 1. And a negative times a positive is negative, so this one will give me 1/2 as a solution. So x is going to be 1/2. This will give me negative 3, and then I had a 1 from up here. Okay. And I have 3 solutions. There can only be 3 solutions because it's an x cubed. So I'm done with this. And you'll notice all 3 of these were in this list. Okay? Now let's look at this bad boy. The first thing I would do with this, since I would see if I could factor anything out, because this is an ugly looking equation. So they all have an x in them, so I'm going to take the x out. That gives me 10x to the third minus 15x to the second minus 16x plus 12. Okay, so I know that there's one real zero here. That's going to be 0. Okay, I'm not sure what else is coming out of here. So my possible rational solution, there's going to be a bunch of them here. So it's going to be plus or minus the factors of 12. 1, 2, 3, 4, 6, and 12. Over plus or minus 1, 2, 5, and 10. Now this makes a whole lot of possible rational solutions because there's what, 2, 4, 6, 8, 10, 12 of them here. Plus all of those divided by 2, so 1 half, 2 halves is a repeat, 3 halves, 4 halves a repeat, 6 halves, 12 halves are all repeats. Okay, so then all those divided by 5, well, all of those are on there. So 1/5, 2/5, 3/5, 4/5, 6/5, and 12/5. And then I can divide all those by 10. Well, I'm only going to get 2 new ones out of that. I'm going to get 1/10 and 3/10. All the rest will be repeats. So what? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 32. 32 possible rational solutions. Not at all fun. Okay, so I could try some synthetic division there to find some of them. Hopefully we find one pretty quickly. Let's try 1. 1 times 10 would be 10, minus 5, that'd be negative. Nope, that's not going to work. Let's try 2. So 2 would give me 20, that would give me 5, that would give me 10, that would give me negative 6, oh, that's going to work, negative 12, 0. Okay, so 2 is also going to be 1. I'm going to get a 0 from here. Okay, now, this thing right here is 10x squared plus 5x minus 6. It is not easily apparent that any of these are on there, so what I can do at this point to make my life super easy is I can just use the quadratic formula here to find the rest of them. So it's going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so this is this cancels to be positive. So this is 60 times 4 is 240. 2 square root of 265 over 20. Yikes. Okay, that's ugly. So this thing has 4 solutions because it's degree 4. One of them is 0. One of them we found using synthetic division, that was 2. These are our rational solutions. If we were doing this over rationals, we'd be done with just those 2. These are real solutions. There's 2 of them, negative 5 plus the square root of 265 over 20, and one of them negative 5 minus the square root of 265 over 20. So do yourself a favor when you get down to a quadratic equation like this, either factor it, or if you can't easily factor it, throw it in the quadratic formula and figure out what the answer is. Okay, there's your assignment for the day. Enjoy that, and I will talk with you later.